Let it bang, bang.
Hello, in this section we will look at QuickSort. A QuickSort is a algorithm which takes an average of O of n log n, and at the best case it takes n log n, and at the worst O of n square. And what n log n means here is that if we have, let's say, thousand of searches or values to look for, then n log n, if we take the base 10, then it will take log 10 of 1000 is 3, so the output will be 3000. But if we take at the O of n square, then the complexity will be huge and the searches will be so many. So that's why O of n log n also is preferred over n log n. But when the values are less, these make no much difference. So that's why we go for any algorithm. But when the values are huge, we have to make sure that n log n should be preferred over O of n square. How quicksort algorithm works is we have to make sure that we can assign any element pivot. We generally assign left or the right one as a pivot. In this case, I have assigned leftmost element as pivot, and every iteration we have to assign it. So these all are the steps of first iteration, and after that all these steps will be repeated in a recursive manner. So in the first step, this is the left element and this is the right. So we have to take care of positions. We have to make sure that these positions are rightly denoted. By right will be the length of array -1, and we have assigned the pivot as an index 0. So when pivot it is at its left, then we have to make sure that we will compare from right elements, and if the right element is greater than this pivot, then we have to swap it. Now when pivot is at its right, we will compare from the left, and we have to make sure that each left element should be less than the pivot, and if it is greater than, then we have to swap it. If not, then we can continue to move like this. So in this case, 5 was the greater, 5 is at its left, so we will compare from the right, and we will see that 1 is, we have seen that 1 is less than 5, so we will swap it. Now interchange the position of the pivot as it is at its right. Now we will compare from the left, and we will see that all these elements are less than, so we will continue, just increase the left pointer or left index, and when they all meet left and right, so we will quit the first iteration, and now we can move ahead with the with the iteration 2. Now as the pivot is reached, we can make sure that the partition 1, this means that all the elements before the pivot are less than pivot, and after the pivot are greater than pivot. In this case, there were no elements greater than pivots. That's why there was no partition 2. But in case, let's say there may be 6 or 7 in this array, so it would come here. So this was the theory. Now we will implement it as it is. As we have implemented all the sorting algorithms, we will implement it using this logic. Now first we will make the code of partition. When the partition code is clear, then it will be very easy to implement quicksort.
Let it bang, bang.